Well. Hello everyone and welcome to a short little electricity demonstration. This will be about a power efficient sequence system that runs on low power and you can do how many sequences you want, and it uses memory cells to actually transfer power over to one system to the other. So it can run like endless amount of sequences on one battery without being really power heavy, to be honest. So how do you build such a system? So the first thing you need, I do this on all systems. This is just the startup. Use red wire because it's power out. So I'll just use power in here, then I use, let's set it on 15 power for starters. So just get power to this. I always put a switch on my system so I can just turn it on and off. Anyways, let's get straight into the sequence system. So how I build it, I actually use memory cells, as I said, to transfer power from the inverted output to the normal output. It just switches between these two when one sequence is done running and sends the power off to the next system. So let's start this up. You will need two branches, you will need a blocker, and you will need a timer, and you will need splitters. You can actually use a branch here instead of a splitter, but I prefer to use a splitter. So how does this work? I'll use green wires for the memory cell, so you can follow along easier. So this memory cell will actually get power from this when it's turned on. As you can see, it's always start in the inverted one. It's always get the electricity here first, before the output. So first off, we need to attach the inverted output into the first branch. Then I switch color to black. Then we need to attach the power into the timer. I will just set the timer directly, so this will run for 5 seconds. Let's say 3 seconds. And then from the output of this first branch, we need to go into the other branch and give it power. And from this one, I use the power out because it only needs 1 power. I can set it to 1 power instead of 2 like the branch out does. And I will use that on toggle on. So this will basically toggle on the timer, as you just saw. And now the output of the timer needs to go into a blocker. I will explain why in a minute. So from the blocker, the power output needs to go into the splitter. And from this splitter, we need to go back into the memory cell and put set. Because when this blocker gets electricity, it sends electricity here and sets off the memory cell. That means this power coming out from the inverted output goes towards the normal output instead. Basically, like deleting the electricity going here and just sends it here instead. So we can just start building the second part of the system. Just so we can attach the last wire here. And this will actually be inside the reset output of this memory cell. This is basically to make sure this memory cell is resetted and actually puts power through here, so it doesn't just like sneak power through here. That's why I reset it before it goes into the system. So now, when this memory cell got the power going here, we need to drag that power over to the next memory cell. Now the first part of this system is basically done. So here we need to think a little bit, because here is where your system will be attached. I will use red wires for this. And the first system is basically just a light. You can do a system, but I just decided to use a light here. So the light is activated, and now you just need to figure out, how much power does this need? So basically I need 1 power to the light, and now the pass-through of the light needs to come back here and hit inside the bottom part of the power in of the blocker. So basically, now when this goes, as you can see, it blocks power, and the power here will go down into this one. So now the first part of the system is basically done, except we need to know the right amount of power here. So it's 1, goes back in, 2, 3, 4, 5. So this branch out here needs 5 power. Now let's start build the second part of the system, and this will basically be a really similar concept. It's basically the exact same concept, to be honest. So this is basically the same system. Now let's start by connecting the memory cell into the branch, and let's go from the branch. Let's power up this timer, and the timer we can set this to, let's say, 5 seconds, and then go down here And the branch out here, because it's a door controller only taking 1 power, exactly the same concept as the light, we can just directly set this to 5 power. And now from this other thing here, we can just attach it into the timer so it toggles on. Now from this we do the same thing again. We block the power to the blocker. And from the blocker we want the power to go into the splitter. So that part is done. Now we can just attach the system here. Attach the system, and this system is basically a door controller. And go back to the pass-through. Bring the pass-through into the blocker. So the power basically goes from the system and back into the blocker around down to the memory cells again. So here we can basically use this again. We can set this so it switches power back to the next system. And the output of this one obviously goes back into the power in of the next system. And this other power from the splitter goes directly into the reset of the other one. Same concept here. Just to make it reset before it uses, so it always puts power through here. So now, this is a pretty unique part of the system, because this doesn't need this splitter. And I'll explain why in a second. So basically, we do the same thing here again. We connect this wire, and we place a timer up, and we just use a blocker. And this is all the parts we need for the last part of the system. So use the default wire again, just to connect this. And we can set the last timer to, let's say, 3 seconds. So this will be 3 seconds, 5 seconds, 3 seconds. So now we can activate this timer. And now, basically, the only thing we need to do is the same thing again. Block the power. Just rewire that. We can block the power here. And now, this part here, this is where it gets unique. Because basically what we do here is that we use the power from the blocker going directly into the set instead of a split. Because we don't need to reset anything more, so we don't need this splitter. So the power on this one, the branch out on the last part of the system, does not use the splitter to use these 2 power. So basically this only needs 1 power, 1, then goes back around into this 2, 3. So it only needs 3 power on this side. So now we can attach the system. So just put it in here, do the pass-through, get the pass-through back around. Pass-through goes into the bottom part of the blocker. Now we actually need to see where this needs, it goes 1 power, 2 power, 3 power. I need to calculate in my head here. 1, it's back 2, 3. Yeah. Now, as you can see, all of these things have already been used. So how do we reset this little sequence here? Yes, the power output on the last one basically needs to go back all the way to the first memory cell. Now we use the reset on the first one. So now the whole system is basically complete. As you can see, the door will be open for 5 seconds, then this one will close and this one will be activated. And when this part is done running, it will basically start over again. This way you can save a lot of power, because I could make this system endless. I can just keep building this middle part all around this wall here, and it will still use the same amount of power. And now we just need to check how much power does this use. So basically we have 1 power here going up here. This is 2 power. Then we have 3 power, 4 power. Then we go here, 5 power plus 4 power here. It's actually 5 power, so we have 10 power. Then we have 1 more here. Then we have the lights. So it's actually 12 power. So we can run this whole system on 12 power. As you can see, all of these components, all the lights, the door controllers, everything runs on 12 power. So with that said, I want to wrap this video up, and I actually want to hear people's input, how people think this system should be used. How can I improve it? Can I make this system even more efficient in power? Instead of using maybe branches here to activate this, can I do it in another way to save power? Like, how would you guys build this? Because I figured out a way how to do this now. I just need help to optimize the system. So basically, how do I optimize the system to be even better? That's my question for you. So with that said, I want to thank you all for watching. And until next time.
Hey, Mr. Sunshine, Mr. Rainstorm, meet me in the conference room, we need to brainstorm. Need some middle ground, need an even keel. But you're at war, picking sides, give me fever chills. Take them both like my flu shot broke. I need to give and take to keep me out of that moat. My head above water, thoughts of those lost this week. All these tragedies stay on repeat like we can't shake shit. I can't speak on it, fist to the sky, but I can't beat on it. Drinking my cup, so I'm gonna sip on him. Cam Newton's probably pissed, he can't stiff on him. All these levels of these relative problems.